Okay, so in your chapter 11 packet, now turn to page 11, and we're going to go over how to simplify radicals that contain variables. So, before we do that, I want to show you a pattern. Okay? The square root of x squared, this and this cancel out, it becomes x. The square root of x to the fourth would be the square root of x squared times the square root of x squared. These cancel out, so that becomes x times x, which is x squared. Now notice, x to the fourth, the square root is x squared because x squared times x squared is x to the fourth. So it was half of the 4. Here we have the square root of x to the sixth. This is the same as square root of x squared times the square root of x squared, which becomes x times x times x, which is x cubed. Notice, x cubed is half of x to the sixth. So let's do one more. Square root of x to the eighth is square root of x squared times square root of x squared times square root of x squared times square root of x squared. X times x times x times x, and it's x to the fourth. So the square root of x to the eighth is you take the exponent divided by 2, and when you pull it out, it's x to the fourth. So when you do the square root of a variable raised to an even power, you just divide that power by 2. So we had square root of x squared, square root of x to the fourth, square root of x to the sixth, and the square root of x to the eighth. This became x squared, x cubed, and x to the fourth. We just divide them by half. So what would we do with something like the square root of x cubed? Now, the square root of x cubed could be written as the square root of x squared times root x. Well, this becomes x, so our answer is x root x. The square root of x to the fifth could be written as the square root of x to the fourth times root x. So that becomes x squared root x. The square root of x to the seventh becomes the square root of x to the sixth root x, which is x cubed root x. And the square root of x to the ninth becomes the square root of x to the eighth root x, which is x to the fourth root x. So you will notice that, oops, just realized I ran out of room on the board. You will notice that every time you do an odd exponent, you end up with root x at the end. So basically what you do is you look at the number, you say what's the highest even number before that, you divide that by 2, so root x to the eighth becomes x to the fourth, but you have a root x. So whenever it's a variable raised to an odd power, you're going to have an extra root x at the end. Okay, so now let's try a few problems from page 11. So number 1 is root 9a squared. Now what I always do is I break it down to root 9, root a squared. Square root of 9 is 3, square root of a squared is a. Number 2, root 18x cubed. I'm going to rewrite it as root 18 times root x cubed. Root 18 becomes root 9 times root 2, or 3 root 2. This becomes root x squared root x, or x root x. Now I have to combine these. Anything outside gets multiplied with stuff that's outside. So 3x, and what's under the radical gets multiplied with under the radical. So the answer is 3x root 2x. Okay, let's look at number 3. Number 3, root 27x to the fourth. I'll rewrite it as root 27 root x to the fourth. This becomes root 9 times root 3, and the square root of x to the fourth is x squared. This becomes a 3. So outside the radicals, 3x squared Still under the radical is root 3. Okay, number 4. Root 12 x to the 6th. Well, I'll rewrite it as root 12 root x to the 6th. The square root of x to the 6th, that is, divide that by 2, so that's x cubed. This becomes root 4 times root 3. That's a 2, so I have 2x cubed. Oops, that's a 3. Root 3. Okay, then number 5, root 124 a to the 5th. I would rewrite root 124 root a to the 5th. Root 124 could be root 4 times root 31, and this would be a to the 4th times root a. 31 and a is going to stay underneath the radical, right? That's going to become a 2, that's going to become a squared, so I have 2a squared root 31a. Okay, number 6. Root 63 x to the 4th. Break it down to root 63 root x to the 4th. This is root 9, root 7, root x to the 4th. That's a 3, that's an x squared. Root 7 stays, so it's 3x squared root 7. Okay? So now, number 7, root 98 m cubed, root 98 root m cubed, root 2, root 49, root m squared, root m, perfect square, 7m. What's under the radical stays under the radical. So that's 7m root 2m. Then number 8, root 80 x squared y cubed. So root 80 root x squared root y cubed. That becomes an x. This is 16 times 5, so root 16 root 5. This is root y squared root y. That becomes a y, that becomes a 4. So outside my radical is 4xy. Still underneath the radical is root 5y. And I'm done. Okay, now number 9. I have root 108 p to the 5th q squared. So root 108 root p to the 5th root q squared. That's obviously a q. This is root p to the 4th root p, and that's p squared. And this becomes, I think this is 36 times 3. Yeah. So it's root 36 times root 3. So outside of my radical is 6p squared q, and then I still have a 3p under the radical. And then the last one, number 10, is root 72 x to the 5th, y to the 7th, z to the 4th. And that becomes root 36 times root 2 times root x to the 4th times root x times root y to the 6th times root y times root z to the 4th. Okay? So, see what I did there? I broke everything down. Now that becomes a 6, that becomes x squared, that becomes y cubed, that becomes z squared. So I take everything that could be pulled out and I write it together, and then left underneath is 2xy. Okay, so that's the end of this video. The next video will go over multiplying radicals.